Um, as a part of APGENCO 2025 electrical engineering, now today our topic is regarding network solution methods. These things are going to be covered in this session. KVL, KCL, node and mesh analysis. Kirchhoff's voltage law. Before going to this, we need to know three things. One is network. Network is a collection of interconnected components like resistors, capacitors and inductors. This is the sample example of a network loop. Any closed path starting from here and it connects the point again to that same end is a loop. We can see L1 and L2, L3 are the three loops. Mesh are same as loops, but a condition that there should not be any inner loops. That means here the point starts here and ends again here. Inside there is no loop inside it. So this is called a mesh. If you take this loop, then there exists two loops inside this loop. Then this is not considered as a mesh. We can see the definition of KVL. It's simply the algebraic sum of voltage sources and voltage drops equal to 0. That means in any circuit, voltage sources is equal to their individual drops. For example, if you consider this circuit, in this this is a closed loop. So in this there are two voltage sources and two passive elements, two resistors. So the sum of these two voltage sources equal to the voltage drop of these two elements. We can see that algebraic sum of all voltage sources and drops is equal to 0. Note, if any branch which is parallel to an voltage source, then in that case the voltages are same. In parallel branches voltages are same. In series circuits the currents are same. If you apply KVL here, we need to consider one thing. While applying KVL, we need to consider either first sign or the second sign. If you starting a loop from here, if you go straight, then the first sign if you consider, then every other element should be considered with first sign. If you go start from here, we find negative sign, so minus 5 volts, and if you go straight, then it is a positive sign, then 4 volts, and when you come here, then this 4 volts is applied across this resistor, so the same polarity will be applied to this resistor, so it is a positive one. So starting it is a positive one, so as the voltages are same, we are directly writing voltage value across this resistor, so positive 4. And if you come like this, the polarity of this resistor is starting element is minus, so minus we have minus V is equal to 0. So by putting algebraic sum, the voltage value is 3 volts. Similarly, if you consider this circuit, we need to find this R in this circuit. The first step is creating loops. Applying KVL, find resistance R by solving those equations. considering the circuit and writing the loops, identifying the loops, and this every element should be indicated with a polarity. So this polarity positive and negative will be decided based on the current direction. If you assume current in this circuit, if you assume that 2 amps is entering in this junction and 1 amp is leaving in this, and remaining current will be leaving from this 6 volts source. So if you assume the current direction like this, then if the current entering into the resistive element, then it will be denoted with positive element. In any resistive circuit, the current direction will be deciding the polarity of that element. So if current enters into the element, then it will be considered as positive. So if you consider loop 1, there is no unknown element to find. So from this first loop we can conclude that total current in this circuit starting is 2 amps. So 1 amp is going in 12 ohm resistor, and the remaining current will be going into this branch. So by considering this, in this R branch the current is 1 amp. So if you apply in the loop 2, if you start from here, the sign we found first is negative. So negative 12 into the current plus the resistor element into current is 1. So R plus first we found the positive sign, as the larger dash is positive 1, smaller dash is negative terminal. So the first we found is positive, so it will be written as positive is equal to 0. So now if you do minus 12 plus 6 means minus 6, so this unknown resistor is 6 ohms. Now KCL. KCL is at a junction, algebraic sum of all incoming currents is equal to outgoing currents. Here incoming currents are I1 and I2. At this junction, leaving currents are I3 and I4. It can be written as I1 plus I2 is equal to I3 plus I4. Let's take an example. In this circuit, if you want to find Ix, so using KCL, assuming the current direction, apply KCL. So first thing we need to assume any current direction, and afterwards apply KVL to find the unknown currents. Okay, first assuming the current direction, as there is an 100 milliamps current source and 1 volt voltage source. So this current direction is fixed, as this current source indicates the direction also. So the volt here, the current I is entering, we are assuming that I is entering here and 10 amps is entering, and the resultant current is Ix. So by using KCL, we divided the currents at this junction, that Ix is equal to I plus 10 milliamps. Now applying this we can, as we want to find Ix, if you apply KCL here, KVL here, then we can easily find the Ix. So if you apply the KVL here, if you start from here, as it is a current source, it may not be used for in the equation. So starting from this here, the positive sign in the resistance we seen is positive. So positive 100 into the current is 10 milliamps, and after passing to this, the sign we found is positive. So positive 100 Ix is equal to 0. By solving this equation, Ix we found minus 1 by 100, that is minus 10 milliamps. The sign indicates that the direction is opposite to here negative direction indicates that the assumed current direction is opposite to the original current direction. So that is indicated by negative sign. Another example, if you consider this circuit, the R is given 1 amp and I1 current is given 2 amps, I4 current is given minus 1 amp, I5 current is given minus 4 amps, and they are asking to find I3 and I6. So we now, to solve this problem, consider the 3 points A, B, C, and every node apply KCL. So at this node A, 2 amps is coming, and outgoing currents are I2 and 1 amp. So incoming current is 2, outgoing currents are 1 plus I2. From this I2 we found. At this node B, here the entering current is at this junction is I2 and leaving current is 4 plus I3. That from this equation we got I3, and if apply similarly at the node C, at this point the entering current is I6 and I3, leaving current is I2, that is 2 amps, not I2, 2 amps. Then the using this I6 is 5 amps. Loop analysis or mesh analysis. This loop analysis or mesh analysis is used for calculating the currents easily in a circuit. Let's consider this circuit, loop 1, A, B, C, D. We are considering A, B, C, D 3 points, and we are applying current loop analysis. In this loop analysis, first assume the current direction. So we are assuming this current is flowing like this, and another in this loop the current is flowing like this. So through current direction we are taking positive, negative, positive, negative, positive, negative. As the current enters, it should be positive. So for loop 1 A, B, D, that means, as we know, if we start from here, the negative first sign we should be taken, minus V1 plus I1 R1 plus here as there is two currents here, one current is coming inwards, one current is going outwards, and then this can be, as this current is entering here, this side is positive and negative. As on the I2 current we taken another loop, so this current direction is this polarity is given positive and negative. For when dealing with the loop 1, then it will be positive and negative. When dealing with the I2, then it will be positive and negative. So minus V1 plus I1 R1, this resistor, and plus I3, I1 minus I2. I1 minus I2 means I1 minus I2. As two currents are flowing in this, we taken the difference of it. So this is the first equation, and next equation is starting from here. The first we see is positive I3, I2 minus I1 plus, as there is a positive element, positive sign, so positive R2 I2, as we see positive, so positive V2. By solving this equation, we can solve the I1 I2 currents. Let's take an example. Find I at, here they are asking to find current at 30 amps. So similarly we can take three loops. Loop 1, if we apply the loop analysis, this equation will be coming. Loop 2, this will be coming, and loop 3, this will be coming. By summing all the things, we can find the I1, I2 and I3 like this. And if you find 30 ohms resistor I2, then at 30 ohms, two currents, the polarity, the current passing here is I3 minus I2. So if you using the mesh analysis, I3 minus I2 is I3 we found is minus 3.87, and I2 we found is minus 1.19. Then the overall sum will be minus 2.8 amps. Super mesh. There exists a single current source in super mesh. Super mesh in the sense in any branch, if we are considering a mesh, then in any branch, if there exists only current source, then it is called a super mesh. So because the voltage drop across it, we cannot find it. So then this is called a super mesh. From this super mesh, what we can derive is, if you apply a mesh analysis here, if you go through this loop, then the current flowing in this will be I1 minus I2. So that we can consider as 1 amp. So with this we can some conclusions we can be derived using this super meshes. After that, if we apply any voltage loop acrosses this, then the currents will be derived. For example, if you take a circuit like this is 1 ohm super mesh. So we can assume the current direction. Current direction is, we need to find I here in this circuit. So the 1 amp is flowing like this, and another current is flowing like this, and remaining will be flowing in this 5 volts circuit branch. So current we have divided that 1 amp is coming here, I is going here, and remaining current is flowing here. So if we apply KVL here, then if you start from here and end here, the polarities are based on the current direction. As current direction we have indicated the polarity. So if you start here, there is a 5 volts, negative 5 volts, minus, as there is a starting thing is minus 5 into I minus I1 is the current, and plus 5 into I is the current here, and as the current direction is in the downwards, the positive is top, so positive 10 I1. After solving this equation, we got 0.5 amps. We now nodal analysis. Nodal analysis, in nodal analysis, this can be applied when there is more parallel branches. So in any parallel branches, one terminal can be taken as reference, and we can find the other voltages. Nodal analysis is mostly aims for solving the voltage values. With this, as we can see, we considering this node as reference, and these 2 points are voltage references. We can take as V1 and V2. At this node, the entering current is this follows KCL. So at this node, entering current is I1 is equal to outgoing currents are I3 and I4. At this V2, the entering current is I2 and I4, and leaving current is I5. That is given here. And after this, for first equation, I1 is the current source, so it is written directly, and I3 is, we can written current as V by R. We are assumed V1 is the voltage across this branch, so V1 by R1, plus at I4 current, I4 is flowing from V1 node to V2. That means the potential difference is V1 minus V2 by R2. Similarly, the second equation also. Now super node. Any branch having a single voltage source without a resistor is called a super node. This gives some analysis to solve the circuits easily. If a branch containing only voltage source, then it is a super node, and it can be analyzed independently. We can derive some conclusions using super nodes. For example, if you consider this, there is only one voltage source in this circuit. So to find the current I, current at 1 ohm resistor is 1 amp. The current at 1 amp, 1 ohm, that means this resistor is 1 amp. How I concluded this is, if you take reference this as reference node, that is 0 volts, then this is considered as V, voltage V. So at this point the voltage across it is directly, this node is applied with 1 volts. So current flowing in the voltage now is 1. So voltage is 1, resistor is 1 ohm, then the current flowing through will be 1 ampere. So we can consider this current as 1 ampere. As at this node the entering current is 1 amp, I is coming here, and leaving current is 1 amp. So if you write KVL here, then the I value will be 0. So considering another example which is having dependent sources, the aim is to find the current I1. So for this, this RL is given 16 ohms. So to find I1, we are applying, as there is more parallel branches, we are applying KCL here with nodal analysis. In nodal analysis, first we need to take one reference is 0, and another potential as V. So at this point, at this node, the entering current is 0.5 I1 current, and leaving currents are I2, I3 and I1. So if you expand this 0.5 I1, the voltage across is V by 20 is the I2, and V by 16 is the I3, and I1 will be, as the current flowing in this resistor is V, and another voltage source is minus 50 volts. So the potential difference is V minus 50 by 40. That is written here. If two voltage sources are seen in any branch, then they should be written as differences of the voltage sources by the resistor. So after solving this equation, we got I1 current as minus 1.17 amps. This minus indication, we assumed I1 current is flowing like this, as the minus indicates the direction is like this. The current is opposite to the I1. Okay, thank you.